Sorry for everybody who didn't have that sound there. Now you do have the sound. So if I press graph, look at y equals x squared. That's pretty predictable, right? And if I look at y is equal to x to the fourth, notice how it looks a little bit different here. See how it flattens out a little bit? That's because if you take a number that's smaller than 1 and multiply it over and over, it gets smaller, right? So like 0.9 times 0.9 is 0.81. Whereas if you take a number bigger than 1 and multiply it over and over, it actually gets bigger. So 1 is kind of the changing point. Look at what happens if I go x to the 10th. That's even more interesting. I look at that graph. Kind of really flattens out, doesn't it? And if we do it again, if we go, let's see, y equals, and I go x to the 100th power, let's see if it can make almost a perfect U shape there. Yeah, almost, right? So that's what happens as you increase that degree. Everybody kind of see that? Okay, good. So y equals x to the 5th, is it going to look more like x squared or x cubed? Looks like x cubed is just going to flatten out more around 0, right? I totally exaggerated that, but you get the idea. Well, okay. Good, good. So let's talk about root functions. Y is equal to the root of x. So I can only take the square root of what kind of numbers? Positive. So the domain of this function is just positive numbers, and we just produce what we call the principal root or the positive root. So it looks like that. Okay. And then we have the next one, which is y is equal to the cubed root of x. Negatives are included because you can take the cubed root of a negative number. So it's going to look like that. I don't like how I did that. I'm going to try it again. That's better. Looks very similar to the square root function, just heads off in the opposite direction. Okay. We have y is equal to the 4th root of x. Which one do you think that's going to look like? It's like the square root of x, just a little bit sharper. And then y equals the 5th root of x. Looks very much like the third, just again sharper in the way that you probably thought. We all good? Okay, so let's put on our thinking caps. These aren't super important, but they are trying to, get you to think about what the heck is going on. Y equals x to the 2/3, which is the same as y is equal to the cubed root of x squared. Let's try to think about what that's going to look like. Okay? So if I think about the domain, what numbers am I allowed to square? Can I square positive numbers? Can I square negative numbers? Yeah, and whatever you square, it's going to become positive, right? But so the domain is all real numbers because you could square positives or negatives. It looks like you're only then taking the cubed root of positives, aren't you? And the cubed root of a positive is a positive. So it's going to use all real numbers, and it's going to stay above the x-axis. So the root thing makes it look like this, but because it's all the way above the x-axis, it also does this on the other side. Now, how would you describe that? Because first hour had an interesting observation. Okay, seagull, thank you. Bird was what I'm going for. All right. If we flip it, if we go y is equal to x to the 3/2, well, now that's a little bit different. So you got y is equal to the square root of x cubed. Well, that's a little bit different. Yeah, because you can't square root negatives, can you? And if you cube a negative, it'll be negative. You can't take square root, right? So you can't have any negatives there in the domain. And so this graph actually starts at 0, 0, and it heads off like that. Now, let's talk about why it heads off the way that it does. Doesn't that kind of look like something halfway between x squared and x? I mean, it's not a line, but it's also not as sharp as a parabola. Well, look, it's x to the 1.5. See what I'm saying? Yeah. So, I mean, sometimes we look at function, we're like, well, why does it do what it does? Well, the math tells us exactly what it does, yeah. Yep, exactly, yep. And then we have our last ones, which would be the reciprocal functions. Y is equal to 1 over x, and y is equal to 1 over x squared. Y is equal to 1 over x, and y is equal to 1 over x squared. So for what value can you not plug in x for? What can't plug in 0. So you have this thing called a vertical asymptote. Asymptote.
Oh, is that like a fake line?
Yeah, and so some people pronounce it asymptote. I like to pronounce it asymptote. Asymptote is also correct. The Greek language says we would really say asymptote, but I just feel like I'm saying but. You know what I mean? If I say asymptote, so I say asymptote. Okay? Yeah. Yeah, it's like the but day of class. You know what I mean? It's like, there we go. That's on YouTube now. All right, and 1 over x is the reciprocal function. What happens if you take the reciprocal of a big value? You get a small value. What happens if you take the reciprocal of a small value? Like, what's the reciprocal of 1 over 100? It's 100. So you get really big values when x is small. You get really small values when x is big. And then the negatives will produce over there. That's the shape that we get. Yeah, I don't know. You guys are really good at memorizing things. I've seen some of the other tests you take. You have to memorize all sorts of things. So I think you'll be okay here. And then we have 1 over x squared. Can somebody predict what's going to happen here? If you square something, it's going to be positive. So take the thing that's in the bottom end, flip it up. There's the collection of functions that you need to commit to memory, along with the definition of a function. What is the definition of a function? Relation in which every element of the domain corresponds to exactly one element of the range. Nice job. Flip it over. We have this page. You'll be done. Okay, so we're going to see what happens when you take these functions and then you transform them. So in this first situation, it says we have g of x equal to f of x plus k. What do you think is going to happen if we add a number to the function? Yeah, it's going to move it up k units. And what do you think happens if we subtract k? It's going to move it down k units. That should be reviewed from last year. We could also take g of x and transform it to be f of x minus c, and g of x would be f of x plus c. Notice about the location of x or of k and c. What's different about where they're placed? One's in the parentheses inside the function, the other one's outside. The most important thing that you can learn through this whole unit is this. If it's on the outside, it impacts the function in a vertical manner. If it is inside, it impacts the function in a horizontal manner. Okay? So anybody know what's going to happen if we subtract c? Right c units. Opposite of what you think. Opposite of what you think. And you actually already know this, and I'm going to show you how you already know this, okay? And then this would be left c units. So for example, if I had x minus 3 quantity squared plus y plus 2 quantity squared is equal to 16, you just took a test on this. What shape does that make? A circle with the center of 3, negative 2. Opposite when it was on the inside, right? Opposite when it's on the inside. Okay, you see that? So you already told me that, so it's no different. So here you're ready to sketch these, and we're going to sketch them quickly. The first thing that we just do is we sketch the parent function. Yep, the first one is a parabola, so we should know it looks like that. The second one looks like... I'm sorry, I'm just going to sketch all the parent functions first, then we're going to go back and do the transformations. Okay, so that one's a square root function. What does the third one look like? Yep, point of origin, that squiggly thing. What does the last one look like? Yeah, the V. Very good. So you should be able to look at each one and know what the original function is, the parent function is. And then we apply the transformation. Is the minus 3 on the inside or outside? Outside. So is it going to impact it vertically or horizontally? Vertically. So it's going to be down 3. Well, that's easy. The next one is the 4 on the inside or outside? It's on the inside. So will it impact it horizontally or vertically? Horizontally. So is it going to move it right 4 or left 4? Right 4. Very good. Opposite of what you think. The next one, the 3. What's that going to do? Left 3 units. How about the 2? Good. Left 3, down 2. And the last one is going to move it. Good. Down 3 and right 4. Down 3 and right 4. Very good. That's pretty quick, right? Good job. Let's do our last part. Now we're going to talk about vertical reflection and horizontal reflection. Suppose you had g of x and it became negative f of x. Negative f of x. Is the negative on the inside or outside? Outside. So it will create a vertical flip. And then we have g of x is equal to f of negative x. Is that on the inside or outside? It's on the inside, so that will create a horizontal flip. All right. Square root of x. What's going to happen if I apply the negative in that way? Vertical flip. So is it going to go this way? Is it going to go that way? Is it going to go that way? So think about if we take this and we vertically flip it. See that? Yep. So it's going to flip it this way. Now, just so we understand, suppose instead of that, suppose it was the square root of negative x. Is it negative on the inside or outside? It's on the inside, so it will flip it this way. You see that? Okay. And then the last one, and then the last situation is if it would be negative root of negative x. That will do both of them. That's a really nice graphic organizer for how the negatives impact the root function. Should be able to see all 4 of those. Okay? We all good? Okay. All right. In this situation, first we need to try to deal with the negative, okay? So what I'm going to do here is I'm going to factor the negative out of the x, and I get negative quantity positive x minus 3. That whole thing squared. See how I factored that negative like that? See that? Everybody good with that? Okay, so you always need to try to start it in that form. So what's that? First of all, what's the shape make? It's a parabola. What does the right 3, or what does the x minus 3 do? moves it to the right 3, and then after I do that, I apply this, which means you do what with it? Horizontally flip it. So if you horizontally flip it, just to be clear, if I take this and I horizontally flip it about itself, you get the same thing, don't you? Do you see that? You don't necessarily flip it over the y-axis at that point. You take it and flip it in the spot that it is. Okay? So I get the same thing. Now, if it would help you to think about this even further, what happens if I square a negative? I get a positive, so g of x is equal to x minus 3 quantity squared. Isn't that exactly what I have right here? Yeah, so it's the same thing. Look at this one. I'm going to factor out the negative here. I get g of x is equal to, and I'm going to write negative parentheses. What am I going to have? X minus 1 to the third. Good. Plus 4. Good. So we're going to apply them in the order of operation. So what's the minus 1 going to do? Well, first of all, what's the shape look like? Yep. So what does minus 1 do? Right 1. What's the negative going to do? It's going to flip it. So instead of starting down and finishing up, it's going to start up and finish down, right? And then what's the plus 4 going to do? Up 4. So this is your shape. Right 1, flip it, up 4. You good? You try the last one on your own. Is that what you got? Good. Okay, that's the basics. Please turn to your homework assignment. All I want you to work on is the first page. So the first page at front and back, that's the easier transformations. Later on we can look at the harder ones, but no need to do that right now. Kind of. Right now we're doing the graphical representation. Then we're going to move to a table. Then we're going to work on actually writing functions. We have to talk about even and odd functions. So we've got a little bit to work with it. But without a doubt, your second worksheet, the harder ones, that's going to be a little bit more challenging. And we'll probably get to that on Monday. I don't think we'll be dabbling tomorrow. I think tomorrow you will most likely have more of a work day, so to speak. But anytime you have a work day, I love to do a checkpoint. So the checkpoints are helpful, but